Good morning, good afternoon, good evening guys, gals and gentlepods, and welcome back to the shed. Only we're not in the shed, we're in the big workshop, because today I'm going to make a start on putting the engine together. So we've got the cylinder head done, so that's all nicely reassembled and fully painted, ready to go back on. So we've done the ports and polishing and adjusted the combustion chamber volumes to get the compression ratio right. So that's all ready to go. So today I'm going to be putting the pistons and rods into the block. I've already put the crank in, so that's good to go. I'm not going to detail and video the whole assembly of the engine because there's plenty of other videos on YouTube about assembling A-series engines. I'm just going to detail this little bit because there's some important details that I haven't seen mentioned in other people's videos about A-series building. So I'll come to that in due course. The results of the flow bench testing on the cylinder head are in. Unfortunately, I haven't brought them with me. But essentially, I've got 10 to 12% improvement in airflow, both on inlet and exhaust, in the mid-ranges of the lift. So the very early stages of lift, 0.25, 0.5, 0.75 even, there's very little improvement, which is not unexpected, to be honest, because the restriction is in the distance between the valve and the seat, so that's to be expected. But from about 1 millimetre through to about 4.5, 5 millimetres of lift, well, all the way up to 6 millimetres in actual fact, there is a notable improvement. It does taper off at the top end, which I think is more down to the airflow limitations of the vacuum cleaner I was using to power the flow bench. So essentially the flow bench that I built works to a degree. It's not great. It's given me a measured improvement. I think with a better designer flow bench and a bigger airflow machine to create the through flow of air, I could have measured greater flow increases across the range and probably at higher lifts. I stopped at 6.5 mil of lift because the readings weren't increasing, so there was no point in going any further, and that I'm pretty sure was down to the limitations of the vacuum cleaner. Anyway, that's enough waffle. Let's get on with the job. Right, so I've got the pistons assembled on the rods and they're just loosely slotted in the holes at the moment. I've marked them up with numbers and a clear arrow pointing the direction to the front. When you assemble these for an A-series, the small bore A-series this is, because the bigger bore, the 1275, the big ends of the rods are cut horizontally. They're cut at 90 degrees to the angle of the rod. On the small bore, simply to allow that big end to go through the bore, they're cut diagonally. Now the important factor is to make sure that the rod is on the right direction. So what you have to consider is the direction of rotation of the engine, and when this piston is on its power stroke, so when the fuel air mixture is ignited and is expanding and pushing the piston down, what you want is for that to be on the upper side of the crank so that it's pushing down that way. If it's that way round, it's weak because you're pushing against the joint. But if it's that way round, you're pushing on the solid part of the rod, so they're less likely to break. If you put them in the wrong way round, you've got more chance of them breaking at high RPM. So that's the first detail. Now, I've assembled these rings, I've gapped them. I've checked they're all got the right gaps in the bore, which you do simply by, with the ring off the piston, place it in the bore, get it level, usually by putting the piston in upside down like that to press the ring into level, and then just check the gap at the joint of the ring. The spec of the pistons will usually tell you what the gap should be. These dictate a minimum 0.010 of an inch gap, and when I measured them, they're all on 11, so we're good to go. And when you assemble the rings onto the piston, stagger the joints of the rings, and also because we've got this cutout, I need to make sure that the joints are all anywhere but in that cutout, because otherwise if I put it in with that joint there, as it comes down it's going to pop out of the ring compressor and snag on that shoulder and probably break the ring. So we want the rings to be at, I generally put the top two rings at 180 degrees opposite each other. So we put them at 45 degrees from the gudgeon pin, wrist pin if you're American, and the joints on the oil ring. The oil ring is made up of three pieces. There's a top and a bottom that are very thin, and then there's this spring in the middle. So just make sure that the joints of the top and the bottom aren't going to snag you up, as I say. So we've got one there. So if I put one there and one round to there, so all of the joints are actually 90 degrees, at least 90 degrees away from each other. And because it's probably going to be at least several weeks before this engine runs, I'm using assembly lube. I'd use assembly lube anyway, but if the engine was going to be running almost immediately, I would probably just build them up using the engine oil that it's going to be running on. So this is assembly lube from Amsoil, American outfit, but it's good stuff. The beauty of it is, as you can see, it's quite thick. It's quite cool down here in the workshop today. It's about 7 degrees, which is less than ideal for building an engine, because obviously things contract in the cold, as we all know, and the gaps between the piston and the ball get smaller, closer. Right, so we've coated that with the assembly lube, and then here we have a ring compressor. So pop that over, tighten that up, and what you need to make sure is that that is flush, because if it's flush at the top, it's flush at the bottom. And the one thing we don't want is it to be stepped, because then the end of a ring might pop out and snag and break. So make sure you've got plenty of tension on that. Again, make sure he's in the right direction, the right way around. Pop number 2 out because that's going to be in the way. We just need some of the piston skirt sticking out below the bottom of the ring compressor so that I can start that in the bore. And then just gently tap round to make sure the ring compressor is flat all the way around. Make sure you've got the piston in the right orientation. Just using the style of a hammer, just gently And there we go. Right, so that's number 1 in. Push that down a bit. I want to get all 4 in, and then I'll flip the block over and we'll hook up the big ends. So, right. And there we go. So that's all 4 pistons in their relevant bores. So now we can turn the motor over. They're not going to drop out. Right. Minor cock-up. These rods were the set I bought off eBay, and they were marked up 1, 2, 3 and 4. Now it's worth bearing in mind on the A series the rods are offset slightly, and it appears that whoever marked them up as number 1 being the flywheel end, not the timing gear end. So when I put them in just now, they were in the wrong places, so they didn't match up to the crank. So I've had to take them back out and put them back in. What I've done is I've put number 4 in number 1, number 1 in number 4, and swapped 2 and 3 over. So the rods line up to the crank. It's not a problem because these are brand new pistons in a brand new bore. It's not like they've got to match up to where they were before. And these rods were from a completely different engine as well. So, but now they do line up to the crank journals. So that's another point worth bearing in mind. Make sure you get them the right way around. What I also need to bear in mind is that when I put the caps on, number 1 is flywheel end, not timing gear end. So we can turn the crank round a bit. Pull the rod up, make sure the journal is nice and clean and the journal of the crank is clean. A reasonable dose of gloop or shmoo, whatever you want to call it. I quite like shmoo. Shmoo's a good name. Right. And then pull that up onto there. Take cap number 4, a smear of shmoo. Now, the bearing shells have got a little tab knocked in that lines up into a slot in the cap, and the same on the rod. So it's tab to tab, like so. And I think we can just gently run them in. And then do the same with number 4. So a generous dollop of shmoo. Rub that around the journal and into the bearing. Pop that up. And this time we want number 1. Notch to notch. And now we can rotate the crank so 2 and 3 are up. Pull them up so we can get to them. Make sure it's nice and clean. Dollop of shmoo, blob of shmoo. Rub that round a bit. just gives it its best chance of surviving the initial startup without doing any damage. Dose of schmoo. I know that sounds rough using an impact wrench, but it is a small impact wrench and I was very gentle with it. So I guarantee it hasn't exceeded the torque required for those big end bolts. That's it. It all turns nicely. Right, I can get the torque wrench, tighten them up, and that'll do. I'm going to leave it at that for this video. As I say, I'm not going to detail all of the building of the engine. I've only done this one because, as I say, I've watched a few on YouTube and these are the details that they seem to miss. So, there we have it. That's how to install pistons and rods. Make sure you get the right orientation. Make sure you get the offset right on the rods and take your time. Lots of lube. You don't want to go in dry. And just take your time over it. Hope you found this interesting, possibly helpful, and I'll see you in the next video. So I'm not going to detail all of the build of the engine, so the next video should be the finally assembled engine connected to the gearbox being installed back in Multi. Could be a few weeks. Thanks for watching. See you in the next one.